In the name of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunity into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 33, oil and gas productions, exploration, production, upstream, midstream, refining, petrochemical, differentiated performance, enabling profit optimization, lecture number 33. Okay, before my lecture, I used to read a Quranic verse. قال ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي اللهم رب زدني علما. O my Lord, open my chest and ease my task for me, and loose a knot from my tongue, that they may understand my sayings. Allahumma rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay, oil and gas production. Oil and gas productions, introductions, we have discussed facilities and process management systems, reservoir and wellhead management systems. We have also discussed upstream facilities, midstream facilities, refining facilities, and we have also discussed petrochemical production facilities. Now we have started utility systems. After that, we will discuss unconventional and conventional resources and environment effects. What is the ultimate goal? Shaping the clean and sustainable global energy. Planned to deliver more than 300 lectures next couple of years. Okay, oil and gas production, Digitality System, lecture number 33, safety management system. Today we are going to discuss. Okay. Lecture number 33, key takeaway points. Safety, systems and functionality, hazard, SIL, ESD, PSD, protections and mitigations layers. Okay, safety system and functional safety. The function of safety system is to take control and prevent any undesired event when the process and the facilities are no longer operating within normal operating conditions. The functional safety is the part of the overall safety of a system that depends on the correct response of the safety system response to its input, including a safe handling of operator errors, hardware failures, and environmental changes, fire, lightning, etc. The definition of safety is freedom from unacceptable risk of a physical injury or the damage to the health of the people, either directly or indirectly. It requires our definitions of what is acceptable risk and who should define acceptable risk levels. So this involves several concepts. First, we will discuss identifying what is required safety function, or meaning that the hazards and safety functions have to be known. Okay, safety system and functional safety. First, the definition of safety is a freedom from unacceptable risk of a physical injury or damage to the health of the people, either directly or indirectly. It requires a definition of what is acceptable risk and who should define acceptable risk levels. This involves several concepts. First, number one, identify what the required safety functions. And second, assessment of the risk reductions required. Number third, ensuring the safety function performance. And number four, some of the primary international standards are set what safety should be, like this. Okay. First, identifying what the required safety functions are. meaning that hazards and safety functions have to be known. A process of function reviews, a formal hazard identification studies that is called the hazard HAZID hazard, and hazards and operability that is hazard studies and accident reviews are applied to identify the risk and failure modes. Okay, number two, assessment of the risk reduction required by the safety function. This will involve a safety integrity level SIL or SIL assessment. A SIL applies to an end-to-end safety function of the safety-related system, not just to component or part of the system. Okay, number three, ensuring the safety functions performs to the design intent, including under condition of the incorrect operator input and failure modes. Functional safety management defines all technical and management activities during the life cycle of the safety system. The safety life cycle is systematic ways to ensure that all necessary activities to achieve the function safety are carried out, and also to demonstrate that the activities have been carried out in the right ways. Okay, furthermore, safety system and functional safety. For the oil and gas industry, safety standards comprises a set of corporate, national and international laws, guidelines and standards. So if you can see here, the first standard IEC 61508, functional safety of electrical, electronics, program, electronic safety related systems. Number two here, IEC 61511, functional safety instrumented system for the process industry sector. Okay, number three over here is safety integrity levels, then protection layers and mitigation layers. Okay, a safety integrity level is not directly applicable to individual subsystem or component. It applies to a safety function carried out by the safety instrumented system, end-to-end sensor control and final element. IEC 6158 covers all components of the EEPE safety related system, including a field equipment and specific project application logic. All these subsystems and components, when combined to implement the safety function or functions, are required to meet the safety integrity level target of relevant functions. Any design using supplied a subsystem and component that are all quoted as suitable for the required safety integrity level targets of the relevant function will not necessarily comply with the required for that safety integrity level or target. Okay. Supplier of the product intended for use in PE, a safety-related system, should provide sufficient information to facilitate and demonstration that the electrical equipment safety-related system complies with IEC 61508. This often requires that the functional safety for the system be independently certified. There is never one single action that leads to a large accident. It is often a chain of activity. There are many layers to protect against an accident, and these are grouped to different categories. First is a protection layer and second the mitigation layers. What is the protection layers? To prevent an incident from happening, for example, a rupture disc, relief valves, etc. Number two, mitigation layers, to minimize the consequences of an incident, for example, operator interventions or safety instrumented system, SIS. Okay, SIS is a collection of sensor, controllers and actuators that execute one or more SIF functions, loops that are implemented for a common purposes. Each SIF has its own safety integrity level, SEL, and all sensor controller and final elements in one SIF must comply with the same SEL limits. Okay, safety system and functional safety. First, we will discuss ESD or emergency shutdown system. Emergency shutdown system to handle emergency conditions, high critical shutdown levels. Number two, a process shutdown system, PSD. Process shutdown systems to handle a non-normal but less critical shutdown levels. Number 3, fire and gas systems here to detect fire, gas leakage and initiate firefighting, shutdown and isolation of ignition sources. Number 3, SAS and the amount of risk. SAS senses hazardous conditions and takes actions to move the process to a safe state, preventing an accident from occurring. The next is the amount of risk reduction, that is SAS. The amount of risk reduction that an SAS can provide is represented by its cell, which is a measure of the risk reduction factor provided by a safety function. IEC 61508 defines a 4-level of cell. So, and the corresponding requirements for the risk reduction factor RFF and probability of failure on demand, PFD, we are going to discuss on the next slide. Okay, this is my last slide. Then we will conclude today's presentation. If you can see here, the first is the safety freedom of the acceptable risk. Okay, second point, safety integrity levels. And number 3, PFD, probability of failure on demand. Probability of failure on demand. And then RRF, risk reduction factor, and safety instrumented system SAS. Okay, we are going to discuss a 4 set of cell. In the first cell here, if we can see here, if the cell level is 1, so the PFD, the probability of failure on demand, will be 0.1 to 0.01. The RRF will be 10 to 100. If cell level is 2, then probability of failure on demand will be 0.01 to 0.001, and RRF, risk reduction factor, will be 100 to 1000. If we are in number 3 here, cell level 3, so the probability of failure on demand will be 0.001 to 0.0001, and risk reduction factor will be 1000 to 10,000. Okay, if the probability of failure will be 4, then the probability of failure factors 0.001 and in between 0.00001, and the risk reduction factor will be 10,000 to 100,000. Okay, thank you very much for your patience now. So this is my conclusion page. Today we have discussed a safety system and its functional safety. Okay. Next topic, we are going to discuss the emergency shutdown and process shutdown. These are a few references. First, Qatar Petroleum, Doha, Qatar. Then Oil and Gas Development Corporation Limited, Pakistan. World Energy Outlook. US Geological Survey. US Department of Energy. Schellenberger Oldfield Glossary. International Energy Agency. Wikipedia. Oklahoma State Marginal Well Commission Pumpers Manual. State Fact Sheets, Northern. NOR6 Standards Norway. The Story of Oil in Pennsylvania. Air Liquid Gas Encyclopedia. Natural gas from wellhead to burner tip. Okay. Together, everyone achieve more. Please do not hesitate to send me your feedback and comments at t.masood.dr@path.edu. You can also send me your input through WhatsApp. I have provided my WhatsApp number as well. Thank you very much for your patience. Please stay at home, stay safe, inspired, and blessed. Thank you very much for your precious time.